most people decide to learn about the Internet of Things, they assume they need to immediately start buying physical hardware components. But physical components are expensive, they're fragile, and for beginners, it is incredibly easy to wire something incorrectly and watch your new microcontroller burn out. We can completely bypass that risk. Instead of buying physical boards, we are going to build our projects inside a completely free, browser-based virtual simulation environment. To set this up, you don't need any specialized software. All you need for this build is a modern web browser and a valid email address. By removing the financial costs and the physical risk of frying a circuit, we create an environment where you can focus entirely on understanding pure logic and design. Open up your web browser and navigate to the Tinkercad homepage. Click the Sign Up button to start the process. You will see a few different options here. It is important that you ignore the educator and student account paths. Instead, you must select the Personal Account option. This ensures you maintain independent control over your projects outside of any specific classroom structure. From there, you can log in using either the Google Single Sign-On feature or by creating a standard email and password combination. Once you authenticate your credentials, the system will redirect you from the login portal directly to your main user dashboard. To fully understand this new interface, direct your attention to the navigation pane on the left side of the screen. You will see tabs labeled Classes and Tutorials. Treat these as secondary educational resources to explore later on your own time. The critical area for our work is the Designs tab. This is your primary hub, where all of your digital blueprints will be stored. Setting up your account this way guarantees you have an isolated, secure environment to test experimental architecture without worrying about organizational restrictions. Now, let's create our first actual project space. Navigate to the Main Action button on your dashboard to trigger a new asset. A drop-down menu will appear. The system defaults to 3D design, but for IoT architecture, you must explicitly select Circuit. The interface will load a new workspace. The blank grid taking up the majority of your screen is your primary engineering canvas. On the right side of the interface, you will find a scrolling component library containing all of your virtual hardware. Use the search bar at the top of that library and type in Arduino Uno R3 to isolate our target microcontroller. Click the Arduino Uno, drag it from the library, and drop it onto the grid. This virtual Arduino Uno will serve as the central processing unit for all of the simulated logic we built. Look at the board's upper edge. Digital input and output pins 0 through 13, used for simple binary communication, like on-off signals. Now shift to the bottom row. Analog pins A0 through A5, used to collect variable data, like exact temperatures. Understanding these distinct anatomical zones is a mandatory step. This layout is the foundation for translating your software code into physical IoT actions. Look at your screen and verify your current state. You should be logged into your authenticated dashboard inside a saved workspace, with exactly one Arduino Uno sitting in the center of the grid. If you see that, you have successfully established a zero-cost, completely risk-free prototyping laboratory. Right now, that microcontroller is a blank slate. It represents pure potential energy, waiting for logic to dictate its behavior. In the next steps, we will start dragging functional sensors onto the grid, wiring them together, and deploying our very first lines of code. You have built the empty vessel. Your environment is now fully primed to bring abstract architecture to life.